Hello everybody. Today lecture is about data organization. This is Dr. Noor Shah. In previous lectures we discussed how to collect data and how do we do sampling. Once you have data in your hands and you present that data in a raw form, so usually we cannot conclude anything from that data. So usually data will be considered in two forms. One is raw data, whereas the other form of the data is organized data. Now, what is the procedure for organizing data? Let's suppose if somebody give you this data, raw data of 50 wealthiest people in the world in this form, you see. But from here you cannot observe anything. If you look into the data, can you conclude anything from this data? So the answer is no, you cannot do anything because you would simply see these are the numbers 49, 57, 38. So what does these numbers basically represent? So if you write this data in this form, okay, like if you organize the data, that is something called organization of data. So if you write data in this form, what would happen? You see, we can conclude from here that this is the region where the people have more money. So most of the people have money if the age is above 56. So this is the advantage of organization of data. If you write that data in tabular form, so we call it what? That is known as frequency distribution. So frequency distribution is used for organizing raw data obtained from scratch in such a way that it could be interpreted easily. You can draw some conclusion from that data in a proper way. So this organization can be done by using tables. The tables will contain either classes, it will contain some tallies, it will contain some corresponding frequencies, it can include cumulative frequencies, it may include percentage of each class or each group as well, based on the frequency. So we usually talk about two types of frequency distribution. One is the categorical frequency distribution, whereas the next one is the group frequency distribution, or you can say that is divided into further two groups. This group frequency distribution, we call it ungroup frequency distribution, and obviously group frequency distribution. So in case of categorical frequency distribution, the variable, the data will be categorical, and that will be qualitative data. So let's suppose we have a categorical data which can be placed in a specific way. That might be nominal, that might be ordinal level data. Okay, for example, if we consider the following blood test for a specific army inductees. Okay, so these are A, B, B, A, B, and you know that these are categorical data, that is a categorical data, and so on. Now if you want to write or find the frequency distribution for it, so it's simple, write A here, and then you will count A's in a row direction, or you may go in a column direction. You say A, so we put one tally here. Then next one, A, B, so you have simply two B's, so there will be two tallies in front of B. Then we have A, B, so we go for A, B, one tally. Then three O's, so there will be three tallies according to O. And how do we draw tallies? So the procedure for tally is you simply draw four lines here, and then the fifth one will be simply across those lines, just to make one group of 5 tallies. Okay, and then we simply count all these groups. You see it's a one group, so its frequency will be 5, and the percentage is obviously 5 by 25, which is 20% if you want to include the percentage as well. And then you see that the next one is 5 plus 2 7, this is 5 plus 4 9, and so on. And from here then you see from the frequency distribution you can conclude that those inductees has 9% who have a O group blood group. It means most of the inductees have a O blood group. Okay, so if we talk about group frequency distribution, or we talk about distribution of quantitative data. Okay, so if we have a large data, and statistics usually that threshold for large or small data is 30. If the data is less than 30, we say it's a small data. When the data is greater than or equal to 30, we say it's a large data. So if the data is large and there is no such repetition in the data is not, the data points are not repeated, then it must be grouped into classes, right? And the rule is that are more than 1 unit width, in which in what is called grouped frequency distribution. For example, distribution of number of hours that both batteries lasted in the is the following. You see, in this case we are considering 24 to 30, that's the class limits, whereas these are the class boundaries we can introduce. We also use sometimes it's important to introduce class boundaries. So the corresponding class boundaries are 23.5 to 30.5, and the frequency is what that is 3, because there are 3 tallies. Similarly 31 to 37, and the 30.5 is to 37.5 if you want to introduce class boundaries, and the frequency is 1. There is only 1 tally, so altogether that's 25. It's just an example what do we mean by group frequency data. So you have to introduce class limits or class boundaries, or maybe both. You can introduce the corresponding tallies. You'll be counting them from the given raw data, and then you simply count these tallies to convert them into frequency. You may introduce, you may use their percentage as well. We may talk about cumulative frequencies as well. Okay, so what are the rules for to construct a group frequency distribution? So rule number 1, we usually say there should be at least 5 and at the most 20 classes. If the data is too big, then you may go for more than 20 as well. But the ideal ones are maybe 10 to 15 classes, or maybe 8 to 15 classes. That's the most ideal ones. It is preferable but not absolutely necessary that the class width be an odd number, whereas the classes must be mutually exclusive. Okay, for example, in this case these classes are mutually exclusive. They are considered to be mutually exclusive even the 20 is included in this group and this group as well. This is considered as mutually exclusive, but this is not ideal, because if 20 is in the data, so there is a confusion whether 20 will go in this, it will be counted in this group or in this group. Similarly for 30, similarly for 40. So this is not ideal. Okay, so the ideal ones should be like 10 to 20, and then 21 to 31, 32 to 42, and 43 to 53. So they are also mutually exclusive. Okay, and the gap between 20 and 21 can be covered by introducing class boundaries. Okay, so they are mutually exclusive. This is the ideal one. You can still use these as well if you know that 20, 30, 40, 50 are not present in the data. So you can go for this process as well. This is also allowed, but that's not ideal, obviously. The next one is the classes must be continuous. Even though if there are no values in the class, if the class has a 0 frequency, you have to include it. There should not be a break in the class in the classes. Okay, the class must be included in the frequency distribution, even though if its frequency is 0. The classes must be exhaustive, which means all the data must be included. You should have enough number of classes to accommodate the complete data, and the classes must be equal in width as well. Every class should have equal width. Keeping one thing in mind, if you are given some classes and you want to find class width, so you see in this case the class width can be found as 20 minus 10 plus 1. If you want to find class width from the class limits, the rule is upper class limit minus lower class limit plus 1. Or we can simply do that, the difference between lower class limits of two consecutive classes, or the difference between upper class limits of two consecutive classes. Whereas in case of boundaries, if you are given class boundaries, the class width will be found as upper boundary minus lower boundary. There is no need of adding 1 to it, right? So in class limits, the class width can be found as upper limit minus lower limit plus 1, whereas in class boundaries it will be simply upper boundary minus lower boundary. So you see in this case the class width will be what? As 20 minus 10, which is 10, and then plus 1, so we get 11. So class width in this case would be 11. The same will be here as well. It's also 11. It should be also 11 here. It should be also 11 here. So the class width must be same. Okay, a frequency distribution can have open-ended classes as well. In that case, we call it open-ended distribution. Examples are, you see, in this case, we say 10 to 20 age, that is 3 individuals, and then after 54, we might have something jumps in the data, and we may not introduce one to accumulate that or accommodate that in one group. So we simply write 54 and above. The same. This is known as open-ended classes. We can have below 110 as well. We can have both as well. We can have below 10 and then above for 54. So we do have this type of distribution as well, which are known as open-ended distribution if it has open-ended classes. Okay, let's do an example by using these rules or introducing these rules. Let's suppose we are given the data that is a high temperature of 50 states, and we are interested to construct frequency distribution for it with 7 classes. There are 50 states, so the data is given for 50, which is greater than 30, so it means we are considering a large data. The procedure is what? You simply look for the largest value in this data, the maximum value. You see in this case 134 is the maximum value. We look for smallest value as well, so we are having 100. So by using largest value and smallest value, we find the range, which will be 34 in this case, and then we divide a range by the number of classes. That would give you class width. That's a maximum value in the data minus it should be minimum, it's not maximum. The maximum value minus minimum value divided by the number of classes. In this specific case, the maximum value is 134, whereas the minimum value is what? That is 100. Let me do some correction here. This is minimum, it's not maximum. Okay, so maximum value minus minimum value divided by the number of classes. So we are interested to have 7 classes, so that must be divided by 7. The 34 divided by 7, which is 4.9, and then we simply approximate that by 5. As in the rules, in the laws, we said that we should have it's preferable to have odd class width. So 4.9 give you 5 odd class. If it was 5.9, you may consider 6. In that case, if it was 5.9, and you may take 7 as well. If you go for that preferable class width, So it is better to have 7, otherwise you can go for 6 as well. Okay, and then you would be starting from 100, the smallest value. You can start from the smallest value or any value below 100 and not exceeded the class width. In this case, you may start from 99, you can start from 98, you can start from 97, 96, but you cannot start from 95. You can start, but then it will basically to accumulate the complete data. To accommodate the complete data, you would need one extra class as well, and then it will increase the number of classes to 8 instead of 7. Usually we do that. It's not a rule. We start from a position or from a number which is a multiple of 5 or a multiple of 10. That's why we are starting here from 100. If it was 101, you should have started from 100 as well. So the first value would be 100, then the next value would be simply 104. The class width is 5, but you see you'll go for 100, 101, 102, 103, and then 105, 104. Once you reach to 104, it will give you a class width of 5. So the first group will be 100 to 104, the next group will be 105 to 109, and so on. Then you tally the data. You will be looking for those numbers, those data points which lies between 100 and 104. The procedure is similar what I explained in previous example. You could go along the rows, you could go along the columns and simply look, this number is lying in the first group or in the second group. So you will first put all the groups in it, and then you will go for the tallies, and then you would move toward the frequencies. And then you would find the numerical frequency as well from the tallies. Okay. The complete distribution is given as like that. You see, we are having classes. You will first go for the classes here, 100, 104, 105 to 109, and so on. Then you will be looking, you can introduce class boundaries as well. Then you will be looking the first number, is it in this group or in this group or in this group. So simply put a tally here, and so on. And then you count all these tallies, which are 2, 8, 18, 13, and so on. So total number should be 50. It will not be less than 50. It will not greater than 50. Because if you made a mistake somewhere, you simply put one extra tally, so that will increase the number of total number of frequency as well. Sometimes you are also interested in cumulative frequency. What is the advantage of cumulative frequency? You see, if somebody asks you how many states are there in which temperature is less than 1.9.5, so you need to compute the sum of all these frequencies. So it's better if you include cumulative frequency. So you don't need to explain what would be the number of states where temperature is less than a specific number. Everybody could read that directly from the table. So sometimes you are interested in cumulative frequency as well. The cumulative frequency distribution is a distribution that shows the number of data values less than or equal to a specific value. Usually we take what? That's an upper boundary. So keeping in mind, when you do cumulative distribution, for that purpose you have to introduce class boundaries. Okay, we don't use class limits in that case. So but that specific example, we may take that as 99.5 to 104.5, and the cumulative frequency will be 2. We would write that 104.5 to 109.5, and the cumulative frequency will be 10. It's simply adding 8 plus 2, that is 10, and then adding 18 to 8, and then adding 13 to it, and so on. You may write this in this form as well, less than 99.5, or you could write that in a class boundary style as well. Like in this case, if you write that in, so we say simply 99.5 to 104.5. In that case, we don't need the first one. We don't need this one, you see. Okay, and the cumulative frequency will be written in front of it. The next will be, you will not allow to write class limits. You would write class boundaries. Then you would write 104 to 109, this 0.5, keeping in mind. And then the corresponding cumulative frequency will be written in this form here, and so on. So we may write these quantities as like that. or you can write in this form as well. It's up to you, both are allowed. Okay, so in this case, the data shown here represents the number of miles per gallon that 30 selected four-wheel drive sports utility vehicles obtain in city driving. Construct a frequency distribution. So in this case, the data is given in this form. See. Now, if you look into this data is a small number of data points, but their number is large, right? Because most of the observations are repeated. So in this case, we are not using a group frequency distribution. We usually use ungrouped frequency distribution. Okay, and how do we do that? We simple write that is the smallest number at the top, that is 12. The next number is 13. Then we have 14, 15, 16 up to 19. Yeah. So and then we simply count them. So in that case, we don't introduce classes. We simply write the numbers as it is, so 12 to 19, and then we count all those numbers. You see, the first number is 12, so you draw one tally. The second number is 17, so you draw one tally for 17. The next is 12, again you draw one tally here. 14, the next tally will be here, and so on. And then we count them together, right? So this is known as, you can introduce class boundaries as well. This is known as ungrouped frequency distribution, because we are not using class limits here, we are not using groups here, we are simply using the numbers. And the reason is we are having a large data, but the data is repeating. So if the data has repetition, okay, whether it's maybe a reasonably large data, if it's a very big data, you have many observations and there is a repetition, so you can still use a group frequency distribution as well. And in this case, if you want to reduce cumulative frequencies, so you see the first part for less than 11.5 would be 0, the next will be 6, then 7, 10, and so on. So the last class should have a cumulative frequency, that is the total frequency as well. So thank you very much for watching, and in the next video I'll be talking about how to draw graphs of statistical data. That's the presentation of data. I hope you like this. If you have any query, any question, you can simply post a comment in the comment box. I will get back to you, and you can subscribe the channel as well. Thank you.